Hi, good morning. I hope you guys had a great weekend. Today, what we're going to do is we're going to talk about inscribed angles. So let's get to it. All right, we've been talking about angles and we've been talking about those type things earlier and triangles and circles. So let's talk about some inscribed angles. If we're looking at these angles, we can see that in inscribed angles, we have in a circle a major arc, which is an arc of a circle measuring more than or equal to 180 degrees. So we can look from A all the way over here to B. We're going to call that arc ACB because C's in the middle of it. That would be a major arc. A minor arc would be one that is less than 180 degrees. So right here, AB is a minor arc. And a semicircle is an arc that is exactly 180 degrees. So that would be the diameter of one. We have a central angle, and a central angle is one that is formed by two radii that are intersecting. Okay, so its vertex is at the center of the circle. Right here, this one right here is 80 degrees. We see that OA is a radius, OB is a radius. They form a central angle right there of X. Okay, and the central angle theorem says that in a circle or congruent circles, congruent central angles have congruent arcs, which makes sense. So if this is X and this arc out here is 80 degrees, if I had another one up here, which was X, then this out here would be 80 degrees also. I think this is pretty simple for you to do, so I would like for you to do example 1. Okay? We also have inscribed angles. An inscribed angle is an angle that the vertex is on the circle and there's two intersecting chords, like this right here. So you have chord ED, chord EF. Okay? This is an inscribed angle. And the inscribed angle theorem says that the measure of this angle in here is going to be 1/2 of this big arc out here, right? So I'm going to give you an example right here. Here's an example. What are the values of A and B? A is pretty easy. I can see that this right here is 60 degrees, right? This right here is an inscribed angle. So the measure of this arc is going to be twice that. Or A right here is going to be 120 degrees. All right? Because our theorem up here says that this arc, okay, is twice of what this angle is, or this angle is half of what this arc is out here. So now B, I know that this right here is 120 degrees, all right? I am asked of what B is. I have 30, 120, but I need to know what this one is over here. This is, all right? So now it's kind of like Sherlock Holmes. How do we figure out what that one is right there? So I know that the whole circle is 360 degrees. Is that going to help me out? I don't know. But if you can remember that I can't draw very well, this right here is supposed to be the diameter. So if this is 120 degrees, I know that this over here, this whole thing has to add up to 180 degrees because it is a semicircle. So this right here is going to be 60 degrees. So if this is 60 degrees, this is 120 degrees, this is 30 degrees, I know that this one right here is going to be half of all that. So 180 and 30 degrees is going to be 210, and half of 210, whoops. This right here, B, is going to be 105 degrees. Okay? So B is going to be 105 degrees. We have a U-try over here. And remember, I'm here if you need me. Okay? Now down here, I've got to move my paper up, but not that. We have 3 corollaries Two inscribed angles that intersect in the same arc are congruent. Well, that makes sense. Okay? So if this measure out here, if they go to the very same arc, then these angles are going to be the same. And they're going to be half of whatever that arc is. An angle inscribed by a semicircle is a right angle. That also goes back to the same thing that we just did. If this is 180 degrees, then this right here is going to be 90, half of that. And the opposite angles of a quadrilateral inscribed a circle are supplementary. So D and B are going to be supplementary. And if you remember, supplementary means they're going to add up to be 180 degrees. Okay? Supplementary angles are two angles that add up to be 180 degrees. So on the other side of that, we have some U tries. Find the measure, okay, up here. Find the measure of each numbered angle in the diagram over here. And I think you can do that. And you can see that this is going to be a diameter between angle 4 and angle 2 is going to be a diameter. So if this is 60 degrees, this is going to be right here 120 degrees. And if this is 80 degrees, this is going to be 100 degrees. The whole thing's going to be add up to be 360 degrees. And I think you can figure out those. All right. The tangent chord angle says that an angle formed by intersecting tangent and a chord has its vertex on the circle. So if we have a chord and a tangent, okay, one that's tangent to that, then that is going to be on the circle. And the next one down here says the theorem says that the measure of angle C is going to be 1/2 of this arc, which truly goes back to the same thing we've been doing. All right. So you have some examples that I'm going to ask you to do down here. In example 4 in the diagram, SR is tangent to circle at Q. If the measure of PMQ, all right, this one right here, is 212 degrees, what is angle PQR? I'm asked for that one. Well, if this is 212 degrees, I know that the full circle has to be 360 degrees. So I'm just going to say 360 degrees minus the 212 degrees. This out here, this whole arc is going to be 148 degrees. We also had, and we know in our theorem, that this angle back here is going to be 1/2 of this. So that's from this one right up here. So this now, PQR, that angle right there is going to be 74 degrees. I hope this helps. I would like for you to complete this assignment, and I will be online between 10 and 11 and 2 to 3 every day. Have a great, or Monday through Friday. Have a great day, and I will talk to you soon. Goodbye.